Well, hello everyone, and thank you for joining this session. So today, as we said, we are going to deep dive into the total cost of ownership of an IoT device. So I like actually to compare the total cost of ownership with an iceberg in order to see what is under the surface. So when we look at the total cost of ownership, the most obvious and visible cost is the cost of components. However, this is only the tip of the iceberg. Below the surface, there are plenty of other costs that are often overlooked, but significantly can impact the overall cost. So today, we are going to see how to reduce this cost. And we will see as well how, in some concrete use case, our customers succeed to reduce their TCO. So my goal today is to present you and to give you some insight and answering the following question. How can IoT device implementation strategies can impact the total cost of ownership? So for that, let's break down the total cost of ownership in more detail. So we have in the total cost of ownership, the visible part, the bill of material, as we say, the cost of components. Then if we go a little bit below the surface, we have all the NRE costs, so the non-recurring engineering costs. So the cost necessary to bring an initial concept to an end product, that is certified and ready to be commercialized. Then once the product is ready, it's all about shipping it, bringing it to the end user. So it's about supply chain and logistics. And once the product is on the field, then it's about maintenance cost. So all the ongoing cost during product lifetime. So let's zoom in into the NRE, the non-recurring costs that include all the costs involved in product development, R&D design, and bringing this device, making a concept to an end product. So we can see different activities. First one is R&D design, involving the design of the RF design, so which includes making the schematics, the layout, fine-tuning the bill of material in order to reach the certification criteria. And certification itself is also a cost. It has to go through laboratory tests. Then the CE marking, the FCC marking is a cost itself. And then after that, there is everything related to reliability and qualification. So reliability and qualification is a way to ensure that the device can be produced at scale and to meet customer demand. But the most important is that if any of these activities fail, if the qualification fails, if the certification fails, we need to come back to the design, to fine-tune the design again, and then we need to redo the certification, redo the qualification. So at the end, the cost could be quite high. So let's look now at the different device implementation and their impact with the different costs we have seen in the NRE. So we have from the left side, we have the most flexible solution, let's say, which consists to use discrete components to implement the bill of materials. So we need to fine-tune here the impedance matching, all the filtering circuits in a way to achieve the certification criteria. So this is the most difficult task because it's using several passive components to do that. We have the intermediate solution that is to use an IPD, an integrated passive device. So such device integrates all the passive components into a single chip, and that is already tuned. So this is a way to provide a mix between a flexible solution and an integrated solution as well. And the most simple way is to use modules that are already certified, that are ready to be in the market, ready to be deployed. So this approach minimizes the design effort and the time to market. And in ST, we have solutions to address each of these different integration strategies, from the full discrete solution that we propose with our reference designs, so showing the WL together with some passive device to implement the bill of material. We have also STIPD, so integrated passive device with integrated balloon that has been fine-tuned to achieve the best performance from the STM32WL. And recently, in January, we have introduced a system-in-package module, the STM32WL5M, that is certified, LoRaWAN certified, and that integrates the RF bill of material inside this product. And here I'd like to show you what has been integrated into this module. So for that, let's look through the metal coating of the module. Let's go inside the molding compound of the module. And if we do that, we see inside the module we have integrated the STM32WL system on chip, the dual-core version. We have as well, on top, we have the crystals, the internal crystals, so to provide a stable clock across temperature. We have the IPD that has been integrated inside this module. We integrated the matching network and all the antenna filters. RF switch to switch from RX-TX path. And optionally, there is also an ST safe inside this device in a way to store the key, the network key, in a secure way. As well as so all of this has been packaged into a 10 by 10 millimeter package. So really high integration scale here. And this one has been certified, LoRaWAN certified, FCC, CE, so it's ready to be deployed. So we have talked quite a bit about hardware design. Now let's focus on protocols. When we talk about TCO, it's really important to consider proprietary protocol versus standard protocol. Proprietary provide a flexible way to implement any features that the network needs to implement. However, this is the most time-consuming process, and it has to come with a full ecosystem. While on the other side, we have standard. And here, standard provides simplicity, interoperability, and faster time to market. And why faster time to market? Because this is the combination of an ecosystem of players that are defining the specification and are creating all the devices around the standard, including device makers, including gateways, network provider, so all the infrastructures as well. So when considering TCO, it's quite important to look at standard as well. Well, so now we have looked through the NRE part of the TCO. When the product is ready to be commercialized, now it's about supply chain and logistics. So in the supply chain and logistics, we can see several things that could impact, like the part longevity, so to reduce the need for frequent redesign and to help to maintain consistency in the production cycles. And also the stock availability, so stock in a way to avoid production delay and to fit with market demand. And at the end is about deploying it worldwide, so the worldwide deployment. And here, modules also constitute a way to reduce this TCO. For the supply chain and logistics, for instance, the WL5M comes with a 10 years longevity commitment. It is into a single device. We integrated many components, so it's a way to simplify procurement and to reduce the complexity of managing multiple suppliers. With a single version of the module, we are able to cover the US band, the European band, and Asia Pacific. So with a single part number, you are able with this module to deploy it anywhere in the world. And through ST channel, we are able to ship it to any location. Well, the other part of the TCO that I wanted to speak today is about maintenance. Once the device is on the field, then it's all the ongoing cost during the product lifetime. And here, several things could impact the maintenance cost. The fact to replace the battery, the update on the field of the firmware, for instance, and the stability of the connection. So let's start first with the battery replacement. And for that, I'd like to show you one concrete use case that has been made by our customers. They are creating a battery-less application to monitor the tree's health. So this customer, ePlant in the US, they are monitoring the tree's diameter, and it grows over time. So they are measuring as well how much the trees get water. They are measuring the solar, also how much sun the trees get, and how well it's capturing carbon. But the most amazing part of this device is that it is battery-powered. It is solar-powered, so it runs without the need of a battery. So that's really the most interesting part, because you cannot imagine for such products, you cannot imagine to have someone to go on the field, to go on the tree, and to replace the battery. So here, inside this product, we have the STM32WL module that has been integrated, and that provides the capability for developers to optimize the power consumption. Optimizing power consumption is something really application-dependent. So this is not a one-size-fits-all solution. It has to be tailored. It's really a tailored process, because developers need to optimize each state of the application in a way to power only what is necessary, when it is necessary, and with the most efficient power supply available. And this is exactly what the STM32WL provides to developers. It provides a set of toolbox that allows them to save the power and to find the features fitting their application requirements. So we can talk for hours about how to save power and which features make more sense. If you're interested, I welcome you to come to our booth to discuss with our experts for your specific use case to see which features fit you best to reduce the power consumption. Now, another part, the best way to reduce the maintenance cost is to avoid issues before they happen, actually. That's the most obvious way to reduce maintenance costs. And here, LoRaWAN offers a solution, firmware update over the air, so FIOTA. With FIOTA, so you can apply security patches, and you can update it efficiently. And ST, we are providing the FIOTA library together with the STM32WL. So this is provided within our CubeWL package on st.com. This feature is compatible with any network server that supports LoRaWAN FIOTA. And this is a way to keep your device up to date, to keep performance across the time, and to make it reliable. Speaking about reliability here, so companies such as metering companies are responsible for the quality of service they provide. So they need to ensure that each meters are reachable by the gateway. And here, there is an example from our customer, Apator. They created this end device, this relay end device, that allows to extend the network coverage. And for meters, it's allowed to reach meters that are across the walls or underground. So this is really the beauty of LoRaWAN relay here, to extend the network coverage where the few miles that is not achievable with the relay. That is the beauty of LoRaWAN relay. If you want to see a live demo, I'd like to invite you to come to our booth. We have the STM32WL5 live demo of the LoRaWAN relay, so showing WL5 on both end device and at relay side as well. We have an energy harvesting demonstration that you can see based on solar panel. And today, I'm also pleased to inform you that our partner, Laguna Space, succeeds to provide a solution and to connect the STM32WL5 to their satellite, to make a direct connection to their satellite with the WL5. So thank you all for listening today, and meet you on our booth to discuss with our experts. And if you have any questions, let me know. Thank you all.